Hello students, welcome back to our channel Diksha Karnataka. So as you all know, your COMEDK exam is approaching. So we have started a series where we are discussing the top 30 questions of all the important chapters from chemistry. So we have already completed it for solutions chapter, so do watch it. So now in this video, I'll be discussing the top 30 questions from one of the most high weightage topic, that is electrochemistry. So you can easily expect 3 to 5 questions from this chapter. So revise all formulas and then please watch this video and try solving these questions. So these questions, most of them are your PYQ, so you can understand what type of questions are asked from this chapter. Okay. So if you are able to solve these questions, you can assume that this chapter is ready for your exam. Okay. So question levels are moderate to difficult. Okay. So let us see these questions. So starting with your question number 1. So calculate the standard cell potential in volt of the cell in which the following reaction takes place. So we have Fe2 plus to Fe3 plus, Ag plus to Ag. Okay. So now E naught of Ag plus to Ag is x volt, E naught of Fe2 plus to Fe is y volt and E naught of Fe3 plus to Fe is z volt. Now we have to calculate the E naught of the cell. So E naught of the cell is equal to E naught of cathode. So which is the cathode here, which is undergoing reduction, that is Ag plus to Ag minus E naught of anode, that is your Fe plus 3 to Fe plus 2, right? But if you see the question carefully, Fe plus 3 to Fe plus 2 value is not given. Rather, we are given with Fe2 plus 2 Fe and Fe3 plus 2 Fe value. So using these two data, we have to derive that value first. So that simple way of doing that is your Latimer diagram. We have Fe, Fe2, Fe2 plus and Fe2 plus to Fe3 plus. Okay. Now let this value be E1. Okay. This value be E2 and this value be E3. Okay. Now according to this one, what we can write is N3E3 is equal to N2E2 plus N1E1. Okay. Now I'll mention the values here. What is E3 value here? E3 is Fe2 Fe3 plus. Okay. Then E2 value is what? E2 value is Fe2 plus to Fe3 plus. Okay. And E1 value is Fe2 Fe2 plus. Okay. These three values I have mentioned. Now let us see the first one. N3E3. From here to here, how many electrons are involved? 3 electrons are involved. So N3 will be 3. Now if you see in the question, Fe2 Fe3 plus value is Z, right? So if I want to calculate, this is the reduction potential. So oxidation potential will be negative of it. So this one will be 3 times of minus Z. That is equal to N2E2. N2 is 1 and E2 value is we have to calculate plus N1. Here number of electrons involved is 2. And E1, again you can see here the reduction potential is given, but I want the oxidation potential, that is Fe2 Fe2 plus. So it will be reverse of this one, that is minus of Y. Then what is my E2 here? E2 value will be 2Y minus 3Z. Okay. But this is what? E2 is your Fe2 plus to Fe3 plus. But if you see the question in the formula, I need Fe plus 3 to Fe plus 2. So I can take the reverse of this one. So I'll get 3Z minus 2Y. Okay. That is your E naught of Fe plus 3 to Fe plus 2. Right. So now we can substitute this value in the formula. So what is the E naught of silver? So for silver it is X minus Fe plus 3 to Fe2, that is 3Z minus 2Y. So if I solve this, I'll get X plus 2Y minus 3Z. Okay. So the correct answer for this question is your option number C. So little lengthy but a good question. So please practice this one. This one is from your Nernst equation and Latimer diagram. Okay. Next question. Okay. So here is a big announcement for all of you, since your COMEDK exams are approaching and many requests have come to us to start a test series. So we have started a absolutely free COMEDK mock test series where there will be 3 mock tests. You will be getting all the video solutions and the PDF of the solutions in detail. So the first test is starting from 29th April. So you can download the question paper from our WhatsApp channel. So the link of the WhatsApp channel will be there in the description section of the video. Okay. And you can also download it from the community section of this channel. So just go there and download it and attempt the test in the exam conditions and come back to see the solutions. Okay. So let us go to our second question. Find the value of equivalent conductance of potash alum. So first you should know the formula of potash alum. So in potassium we have K2Al2SO4 whole 4. Okay, this is the formula. So just we have to add for this one. For K plus it is 73.5. So 73.5 into 2 plus for aluminum it is 189. So 189 into 2. And then for sulfur it is 160. So 160 into 4. So if we add this, we'll be getting around 1165. Okay. So the correct answer for this question is option number B. Okay, next question. Question number 3. When a lead storage battery is discharged, so what happens? So sulfuric acid is consumed. So here H2SO4 gets converted to PbSO4. So the correct answer for this question is option number D. Okay, next. During electrolysis of a solution of AgNO3, 9650 coulombs of charge is passed through the solution. What will be the mass of silver deposited at the cathode? So this question is from your Faraday's first law, right? So in Faraday's first law, we have M is equal to Z into I into T. This IT is nothing but charge, so I can write Z into Q. Now what is Z? Molar mass divided by N into 96500. So silver molar mass is 108. For silver, the reaction is Ag plus 1 electron gives Ag. So number of electrons is 1 and then 96500 and charge is 9650. Okay, so if we solve this, we'll be getting around 10.8, right? So the correct answer for this question will be option number B, that is 10.8. The next question, limiting molar conductivity of NaBr. So we need NaBr, right? So first of all, there should be Na. So all the options are having Na. Okay, next option should have Br. So here it is Br, here also it is Br. But here you see NaOH and NaBr. There's nothing to be cancelled. But you see second option NaCl and KBr is there. So what extra is formed here? KCl extra is formed and then that KCl has to be subtracted. So the correct answer for this question will be option number B. Easy question from your Kohlrausch law. So many questions have been found in Kohlrausch law. KCl generally not many questions were there from Kohlrausch law, but in COMEDK you have more questions also from this one, Kohlrausch law. Then the E naught of the cell for this reaction is given. They calculate the value of equilibrium constant. So this formula, this question is little change here. It is minus 0.8277. Okay. So now if you solve here, E naught of the cell is equal to plus 2.303 RT by NF. So we can put it by 0.059 by N log of K, right? This value is there. So I'll erase this one. So now we can solve it. N value is your 1, right? So we can have log K is equal to E naught of the cell is minus 0.8277, N is equal to 1 by 0.059. Okay, so just we can, for example, we can take it like 0.827 by 59. Okay, for easy calculation, 827.7 by this one. So if you can see, this value will be coming around 14. Okay, minus 14. So K value will be equal to 10 to the power of minus 14. So the correct answer for this question will be option number A. Okay. So like, you know, 14 6 is somewhere around 84, right? So somewhere around 800 is there. So the answer you can guess is 10 to the power of minus 14. Okay. Next is question number 7. Predict the pH of the following half cell if oxidation potential is 3.005. Okay. So now if you see this question, oxidation potential, how to calculate? E of the cell or E of the electrode is equal to E naught of the electrode minus 0.059 by N log of H plus, right? So now if you calculate what is E naught, E of the cell is given to you 0.3005, and for hydrogen electrode, we know for hydrogen electrode the E naught value is assumed to be 0. So minus, I'll take it as 0.06 for easy calculation, 1 log of H plus, right? Now if I solve this one, this is 0.3005 divided by 0.06 is equal to minus log of H plus. So minus log of H plus is nothing but pH value. So this one we can take it like 0.30 by 0.06, right? So we'll get around 5, right? So the correct answer for this question will be option number C, that is 5.085. Okay. So now let us see the next question. calculate the value of infinite molar conductance using the appropriate molar conductance of the electrolytes given in the table. So first one is your, so the question is given, we have to find for HOAC. Okay, so first you find where this OAC part, okay, the acetate ion, where it is present in NaOAC. So I'll take lambda of NaOAC. Right, now I need H value, so from where I'll get from lambda of HCl. Now if you see these two, if I add these two, I'll getting extra is NaCl. So I have to subtract it from NaCl. Right, so what are the values I'm getting? This is 91 plus HCl is 426.2, and then for NaCl it is 126.5. So if you solve this one, the correct answer for this question is 390.7. So the correct answer is option number C. Very easy question. So you can see Kohlrausch's law every year. So these are some of the previous year papers. So Kohlrausch's law questions are asked again and again. Okay. So that is one point what you have to revise properly. Then is reduction potential for a cell reaction Mn plus n electron M, the Nernst equation for the electrode potential for any concentration measured with respect to standard hydrogen electrode is. So we know the equation is Mn plus give you M. So E naught of the cell minus RT by NF log of product by reactant. So 1 by Mn plus concentration. So the correct answer for this question is option number A. Here what is the wrong? This M concentration is not taken. Here if you are taking log, it has to be 2.303. That is why this is wrong. And here what is the problem? Here it is E of the cell is equal to, I think both the options here, okay, this is 1 by M, right, the product by reactant. So this concentration is taken to be 1 divided by 1 by Mn plus. So this equation is also incorrect. Next, which one of the following has a potential more than 0? Okay, so if we see, that will be the formula E of the H, I'll write like H plus 2 H2 is equal to E naught of H plus 2 H2 minus 0.059 by 1 log of 1 by H plus concentration, right? So now if I take here 1 molar, log 1 is equal to 0, so we will get this value as 0. This is already 0, so minus 0.59 by 1 log of 1 by H plus concentration, right? But now if you see here log of 2, so if I substitute here 2, so minus 0.059 by 1 log of 0.5, right? So now if you solve this, this value will be negative. So negative will get a positive value. Positive value will be more than 0. So the correct answer for this question will be option number B. Okay. Next question is when 965 coulombs of electricity. So again, this is from your Faraday's law. Similar question we have solved. M is equal to Z into IT. So 108 divided by 1 into 96500. Here charge is 965, so that is equal to 1.08. So the correct answer for this question is option number C. Okay, next, corrosion of iron is essentially an electrochemical phenomenon where the cell reactions are. So we know Fe gets oxidized to Fe2 plus and the dissolved oxygen in water is reduced to OH minus. Okay, so this is direct for fact-based question. Correct answer for this question is option number A. Next question number 13, the EMF of a cell containing sodium and copper electrodes is 3.05 volt. So we know E naught of the cell is equal to E naught of cathode. So which is the cathode here? Copper. Okay. So you should always remember left side is for oxidation, right side is for reduction. Okay. So cathode minus anode. So E naught of sodium. Okay. Now the question is asked if the electrode potential of copper is 0, so this value is 3.05 and this value is 0.34 and I need to find for sodium. Then what is the reduction or electrode potential of sodium? So if I solve this, we'll get 0.34 minus 3.05, that is equal to minus 2.71 volt. So the correct answer for this question is option number A. Okay, so we know sodium is a metal, its reduction potential will be negative. So that is why we are getting negative reduction potential of 2.71 volt. Okay, very easy question again from Nernst equation. Next, the space in the dry cell is filled with. So dry cell is filled with MnO2, ZnCl2 and NH4Cl. So the correct answer for this question is your option number C. So this question is from your commercial batteries. Okay. Next question, the standard electrode potential of Daniel cell is 1.1 volt. What is the standard gives free energy for the reaction? So we have this formula, delta G is equal to minus NF E naught of the cell, right? Now at equilibrium for this one, Daniel cell is your copper zinc cell where N value is 2. So I can substitute 2 into 96500 into E naught of the cell is 1.1 volt. So if I solve this, the correct answer will be minus 212.3 kilojoule per mole. Okay. So the correct answer for this question is option number B. Okay, very easy direct based questions. Now coming to next question, the cathode reaction in the dry cell. So if you know dry cell, again just now we discussed MnO2 NH4OH will be there. Reduction will take place. So the correct answer for this question is option number B. Zinc is the anode, so we can eliminate these two options directly. Okay, next question. Lambda naught M for NH4Cl, NaOH and NaCl are given. Calculate for NH4OH. So let us first note down the values. For NH4Cl, the value is 130. Then lambda naught M for NaOH is 248. And then lambda naught of NaCl is 126.5. We need to calculate for NH4OH, right? So first of all, you see in which compound we will get NH4. That is from NH4Cl. So we'll take first that one. Next, we need OH. OH is present in NaOH. So just add that one, lambda naught of NaOH. Now you see, we will take NH4 and we'll take OH. What is left extra? NaCl. That has to be subtracted. So lambda naught of NaCl. So if I add this one, 248. Sorry, first is your 130. We'll add it serially. So first is NH4Cl, that is 130 plus NaOH is 248 and then NaCl is 126.5. So if we solve this, we'll be getting around 251.5. So the correct answer for this question is option number A. Okay, direct easy based question. Next, in the electrochemical cell, the reaction will be feasible when? So for reaction to be feasible, delta G has to be negative, right? That is the first condition. So we can eliminate all these options from here. Now if delta G is negative, we have this formula, right? So if this one has to be negative, this value has to be positive. Because if this value also comes out to be negative, then negative will become positive and delta G will become positive, which is not required. So E naught of the cell must be positive. So correct answer for this question will be option number A. Okay, next, the standard EMF of the cell Zn2 plus is 1.56 volt. If the standard reduction potential of Ag is 0.8 volt, the standard oxidation potential of zinc is. Okay, so this question is again from your calculation of EMF of the cell. Very simple question. See, E naught of any cell is equal to E naught of cathode. So which is my cathode here? Ag plus 2Ag. Okay. So please remember, left side is always anode and right side is always cathode. There is one easy way to remember this. You can remember lone. L stands for left, O stands for oxidation, A stands for anode and the charge of the anode is negative, right? So there is always left side, the anode one, where oxidation takes place. So E naught of left side is anode and right side is your cathode. So E naught of a cathode, that is your right side, minus E naught of anode, that is Zn2 plus 2 Zn. We are taking the reduction potentials. So E naught of the cell is how much? Given to is 1.56 volt, okay, and E naught of silver is 0.8 volt and minus E naught of Zn2 plus 2 Zn. So what will be the value of E naught of Zn2 plus 2 Zn? So that is your, we'll get around 0.76 minus, okay. Now the question has asked you to calculate the oxidation potential. So oxidation potential will be the reverse of this one, that is plus 0.76 volt. So the correct answer for this question is option number B, that is plus 0.76 volt. Okay, next question is on the molar conductivities. The molar conductivity of NaOH, NaCl and BaCl2 at infinite dilution are given. So let us note down their values first. So for lambda naught M of NaOH is 2.481 into 10 to the power of minus 2 s meter square mole inverse. Next one is given for NaCl. So for NaCl, the value is 1.265 into 10 to the power of minus 2. So it is very important that you note down the values correctly. Then we need for BaCl2. The BaCl2 value given is 2.8 into 10 to the power of minus 2. Okay. Now question is asked for barium hydroxide. Okay. Now if you see this properly, we need first is barium. In which of the following will get barium? That is the third one. So I can take lambda of barium chloride. Now the next one is required OH ions. OH ions is present in NaOH. But you see we require 2 times of OH ions. So I'll take this one 2 times of OH ions. Right. Now if you see this one, what is the extra that we are forming here? So we are getting 2 chlorines here and 2 OH here, right? And 2 Na here. So we can subtract, we need barium hydroxide, the extra is Na and Cl. So I will subtract minus 2 times of lambda naught of NaCl. So just substitute these values. For barium chloride it is 2.8 into 10 to the power of minus 2, plus for sodium it is 2 times of 2.481 into 10 to the power of minus 2, then minus 2 times of NaCl is 1.265 into 10 to the power of minus 2. So once you solve this, the value you will be getting around is 5.232 into 10 to the power of minus 5. The correct answer for this question is option number A. Okay. Okay, now let us go to the next question. Consider the half cell reactions E0 cell for the given reaction is. So what we have to do is, 2 reactions are given. We have to identify how can we get the third reaction from these 2 reactions. So now you see in any reaction, the electrode number should be same. Here the number of electrons is 2, here the number of electrons is 1. So let us multiply this equation with 2. So what is the equation? First I am having Mn2 plus 2 electron is Mn. Okay. And the second one is 2 Mn2 plus is giving me 2 Mn3 plus, okay, plus 2 electrons. Now if I add these 2 reactions, okay. So here see in like enthalpies and other questions we used to multiply the 2 to the value also, but in this type of in electrode potential we need not add, okay. So do not multiply this one with 2, clear. Now if we add these 2 reactions, what I will get? So 2 Mn2 plus 1 Mn2 plus, I'll get 3 Mn2 plus, right. Then these 2 electrons will get cancelled, and here we have Mn plus 2 Mn 3 plus, right. So now what we have to do is just we have to simply add these 2 values. So I'll get minus 1.18 and minus 1.51. So if I add this one, I'll get minus 2.69. So now if you see delta G value will be minus 2 into F into minus 2.69. So we will get plus value. So the reaction will not be spontaneous or the reaction will not be forward. So minus 2.69 and no. So the correct answer for this question is option number D. Okay. Now coming to next question, how many gram of cobalt metal will be deposited when a solution of cobalt chloride is electrolyzed with a current of 10 ampere for 109 minutes. Okay, so this is again the question is from Faraday's law. So we have to use the formula M is equal to Z into I into T. So Z is what? Molar mass by N by 96500. So cobalt molar mass is 59, and if you see the charge is here cobalt plus 2, so N will be 2 into 96500. Now current given is your 10 amperes and then time given is 109 minutes, which must be converted to seconds. Okay. So now if you solve this, you will be getting the value around 20. Okay. So the correct answer for this question is option number B, that is 20. Okay. Now coming to next question. Okay. So the E0 of the cell is given. To increase the EMF of the cell, what we should do? So first let us write the equation. E of the cell is equal to E0 of the cell minus 0.059 by 2 log of. Now if you see in the log we have chlorine minus ion, okay, square Zn2 plus ion, and then we have in this side pressure of chlorine. Okay. Now they are asking question that the EMF of the cell can be increased, right? Now this term, whatever value comes in this term has to be subtracted from E naught of the cell to get E of the cell. Now if this term is small, okay, this value is a small value, then we will be subtracting a small number, and as a result E of the cell will increase. So we have to see how we can do that this value comes out to be a small number. Now let us see, if we increase the Zn2 plus value, then this log value will increase, then overall value will increase. So we have to subtract a bigger number, right? So then the value will not, the E of the cell will decrease in that case. Now Zn2 plus should be decreased. If we take Zn2 plus and we decrease it, so this log value will be a small number, overall will be a small number, and we will be subtracting a small number from this one. So we can say E of the cell can be increased in this case. Cl minus should be increased. Again, if Cl minus is increasing, right, the whole value will increase, log value will be a bigger number, we are again going to subtract a bigger number. So E of the cell will again decrease in that case. Now partial pressure of the Cl2 is decreased. So if P of the Cl2 will decrease, the denominator is decreasing, so the fraction value will increase, log value will increase, the whole value, this one, will increase, and then E naught of the cell, we have to subtract a bigger number, E of the cell will decrease in that case. So the correct answer for this question will be option number B. Okay, so this is very conceptual question. Next question, the reduction potential of an electrode can be increased by. So if you see again this one, reduction potential of any electrode, E is equal to E naught minus 2.303 RT by NF to log of 1 by Mn plus, right? So this is the reduction potential of any electrode formula, increasing the area of the electrode. So there is no relation of area in the formula. So this one is not relevant. Now decreasing the temperature, again the same thing. See, if we decrease the temperature, this value will decrease, this value will be a small number, and we are going to subtract a small number from this one. So the reduction potential will increase. So this can be an answer. Now if you increase the temperature, if we increase the temperature, this overall value will increase. We are subtracting a bigger number from E naught value, so E value will become less. So this one is definitely not the answer. Now decreasing the concentration of metal ion. So if you decrease the concentration, here if the value is decreasing, overall it will be a bigger value, right? So we are subtracting a bigger value from E naught of the cell, then E of the cell will again decrease. So to increase, then we have to decrease the temperature, which is directly related. The correct answer for this question will be option number B. Next, an electric current is passed through silver and water voltmeter connected in series. The cathode of silver voltmeter weighs 0.54 gram more after the electrolysis. The volume of O2 liberated is. So this question is very, very important. Okay, so here you have to first understand that some amount of silver is deposited. So on one side silver is deposited, on another side oxygen is deposited. So I can say number of equivalents of silver deposited is equal to number of equivalents of O2 deposited. Okay, these both are equal. Now what is number of equivalents of silver deposited? How to calculate that? We have this formula, M is equal to Z into IT. So Z is what? Molar mass, okay, divided by N into 96500 into I into T. Now what is your equivalent mass? If you know, equivalent mass is nothing but given mass by molar mass into N factor. So this is my given, so I can write mass divided by molar mass, okay, this value into N, that is equal to I into T divided by 96500. This is nothing but number of equivalents, right? So now we can calculate for magnesium what is the number of equivalents that is deposited. Okay, so now the question is what? We have to calculate the number of equivalents of magnesium, the number of equivalents of silver. So mass deposited is 0.054, right? Molar mass is 108 and into N. So N factor here is your 1. So if I solve this, I'll get 0.000 and 5, right? So now the number of equivalents deposited of oxygen will also be same. Okay, so what is the number of equivalents of oxygen? that is 0.0005, right? Now we have to calculate the volume. So here something you should know, one equivalent of oxygen occupies 5.6 liters. Now from where this number has come? So if you know, in oxygen we have this formula O2 minus 2O2 minus gives O2 plus 4 electron, right? Equivalent volume, if I want to calculate, that is equal to molar volume by n factor. So that is 22.4 is the molar volume, n factor is 4, that is 5.6 liter. So that is why one equivalent of oxygen occupies 5.6 liter. Now how many equivalents of oxygen we have? 0.0005 equivalent. So one equivalent occupies 5.6 liters. So this many equivalents will occupy how much? So volume occupied will be number of the volume occupied by one equivalent is 5.6 into 0.0005. Okay. So now if you solve this one, we will be getting around the answer will be getting, can just multiply here. So 280 we are getting, then we have this many decimal places, so we will be getting around 2.8 centimeter cube. Okay, just multiply it. So this is liter, so we can tell into 10 to the power of 3 for milliliter, right? So that is your 5.6 into 5, so we'll get 2.8. Okay, so the correct answer for this question is option number D. Please check this question once again. I'll repeat once again what we have done. So Ag is getting deposited on one side and oxygen is getting deposited on another side. Number of equivalents of Ag deposited will be equal to the number of equivalents of O2 deposited. So from the given data, 0.54 gram, 0.54 gram of Ag is getting deposited. So from that we can calculate how many equivalents of silver got deposited, and same will be the number of equivalents of oxygen got deposited. Now the point is to calculate the volume. So one equivalent volume of oxygen occupies 5.6 liters. So these many equivalents will occupy how much volume? So 0.0005 into 5.6. Okay. So the value we will be getting is 2.8 centimeter cube. Okay. So now let us see the next question. The volume of H2 obtained at STP when magnesium obtained by passing a current of 0.05 ampere through the molten MgCl2 for 32.2 minutes is treated with excess of dilute HCl is approximately equal. So this question is very similar to the previous one. So the question is, we have to calculate first again on one side H2 is getting deposited, on another side magnesium is getting deposited. So according to this we'll get number of equivalents of magnesium deposited will be equal to number of equivalents of H2 deposited, right? So first let us calculate the number of equivalents of magnesium deposited. So if we have this formula, that is M is equal to Z into I into T, right? So I can calculate here M divided by the molar mass of magnesium into N into 96500. So that is equal to into I into T, right? So here we have mass deposited is we have to calculate here. So I can write number of equivalents of Mg will be I into T. So current is here 0.5 ampere and time is 32.2 minutes, then convert it into seconds, divided by n factor is 2 because magnesium is getting deposited. So we need not consider this n factor here because we have taken this n factor for number of equivalents. So here this value is M divided by molar mass into N. This is nothing but number of equivalents, right? The one which we have solved in this one, this formula. Okay. So this one will be equal to divided by 96500. So number of equivalents we got 0.5 into 32.2 into 60 divided by 96500. Clear? Now this one is also equal to the number of equivalents of hydrogen deposited. Now like how in the previous question we multiplied the volume occupied by one equivalent of hydrogen. So the volume occupied by one equivalent of H2. Okay. So that is your 11.2 liters. Now how this value is coming? If you have seen H2 reaction is H plus 2 electrons is H2, right? So now if I want to calculate the equivalent volume, it will be molar volume by N factor. So what is the molar volume for hydrogen? It is always 22.4 liter. The N factor here is 2, so we'll get 11.2 liter. So this value into 11.2 you have to do. Okay. Then the units are in centimeter cube, so just multiply with 10 to the power of 3 to get in terms of ml. So the correct answer will be here 112, that is option number D. Okay. So this calculation also is the previous question, and this question is very, very similar. You have to first calculate the number of equivalents. Once you get number of equivalents, multiply it with the equivalent volume. Okay. So for hydrogen, the equivalent volume is 11.2 liter, and for the previous one was your oxygen. For oxygen, the equivalent volume is 5.6. So molar volume by N factor you have to do. Okay. So this question answer will be 112 centimeter cube. Okay. Now let us see the next question. This question is here from Faraday's second law, right? So when there is cells are connected in series, M1 by M2 will be equal to E1 by E2. So same quantity of current is passed through copper sulfate and AgNO3. The solution 2.7 gram of silver is deposited. Okay. Then the amount of copper deposited is. Okay. So we have this formula: mass of copper deposited by mass of silver deposited will be equal to the equivalent weight of copper by equivalent weight of silver. Okay. Now if you see here, mass of copper deposited we have to calculate, and mass of silver deposited is already given 2.7 gram. Now what is the formula for equivalent weight? So equivalent weight is nothing but molar mass by N factor. Okay. Molar mass by N factor. So now if you see for copper, the molar mass is 63.5 and the N factor is 2, right? Because copper 2 plus gets reduced to give you, with 2 electrons it get reduced to give you copper. So we have this one 63.5 divided by 2, and the equivalent weight of silver will be 108 by 1, because silver reduction potential, how does it take place? Ag plus 1 electron is giving you Ag. So N factor here will be 1. So we will have 108 by 1. Okay. So now just solve this one. M of Cu, or mass deposited of copper, will be 63.5 into 1 divided by 2 into 108 into 2.7. Okay. So now if you solve this, the value will be getting around is 0.8. So the mass of copper deposited in this series will be your 0.8 gram. So correct answer for this question is option number D. Let us see the next question. In a dry cell, which of the following is an electrolyte that is used? So in dry cell, the electrolyte used is your ammonium chloride. So the correct answer for this question is option number C. Next cell, in a fuel cell, which of the following can be utilized as a fuel? So hydrogen and oxygen can be used. So the correct answer for this question is option number C. Okay, and the last question, an increase in the molar conductivity in the conductivity equivalent of a solid electrolyte with dilution is primarily due to. So there is two things. Whenever we dilute the electrolyte, molar conductivity always increases, right? So for strong electrolyte, it increases because the mobility of the ions increase, and for weak electrolyte, it increases because dissociation of the ions increases, right? So here it is given for a solid electrolyte, what happens when you add, the mobility of the ions increases, and thereby the molar conductivity also increases. So the correct answer for this question will be option number A. Okay, increased ionic mobility of the ions. Okay, so these were the top 30 questions from your electrochemistry chapter. So please revise the concept and then do these questions. Just if you have any doubt in any question, you can comment down. So I'll be taking it in my next video. And if you have found this video helpful, please like, share and subscribe our channel. Thank you.